Hello and welcome to Cloud Native Apps. I'm Darius Liktorius. I'm a cloud solution architect here at Cognizant Softvision and working on enterprise customers, helping them realize the advantages of the cloud and moving their workloads over to it. I've been in technology for 25 years and or just over that, and I've spent just over 7 years with both AWS and Azure respectively, working on projects involving both of them. My focus, as I mentioned, is solutions architecture, but I've done data related architecture and performance optimization, as well as software development and infrastructure engineering. And I co-founded Microsoft Cloud South Florida. So you might think that I'm a little bit biased towards Microsoft Azure as a platform, and somewhat I am. That said, I believe that the leading cloud platforms all have their fortes and benefits. And so with this particular presentation, we're going to go through various items. First, I wanted to discuss digital transformation and how that relates to the cloud and to COVID-19 that we've been, having to go through as a society. I also will touch on what is the true definition of cloud computing. Many have a misnomer or a misunderstanding of that. And then we'll also be looking at what a lift and shift is versus a transformation. And then what exactly is a cloud native app? Cloud native services will go through the list of what are some of the more popular cloud native services. There are so many out there that we just simply can't cover them in such a short period of time. And then we'll have a couple working examples as well, some demos there. So from a digital transformation standpoint, over the past year, since COVID took hold, you can see the change in spend for organizations for software as a service, which is SaaS, as well as public cloud solutions. There's a vast increase in adoption of those types of workloads, even more so than physical infrastructure. In fact, you'll see that there's actually a decline in physical infrastructure as it relates to traditional on-premises servers and data centers. So we're seeing a massive shift from maintaining your own infrastructure and maintaining your own hardware to moving those workloads into the cloud. And we'll talk about what that truly means here in just a little bit. So interestingly enough, this here reflects just how much each segment and overall the entire industry overall of enterprise businesses and small businesses have actually changed their plans because of COVID-19 with respect to cloud adoption and cloud usage. So as you can see, there's been a massive shift towards the cloud over the past year and a half. And this is the actual percentage breakdown of the various vendors and subsections or subsegments of those vendors within this particular analysis and breakdown and survey, where we see just which vendors and what type of workloads are benefiting. So you can see that Microsoft Azure has had the biggest increase in adoption, followed by Microsoft software as a service solutions. Specifically, that would be like Office 365, that would be Microsoft Teams, etc. And AWS not too far behind at all. And you'll see that as you just work your way down, most of this is service-oriented, adoption, online service-oriented adoption, and some of it, of course, is physical. But you'll see that the more traditional approach, such as VMware licensed software, Oracle licensed software, these are all on the decline, including Microsoft's own licensed software. By licensed, we mean acquiring the licenses in a capital expenditure type model. So they're not being paid for on an operational expenditure basis on an ongoing perpetuity, monthly, so to speak, they are actually reducing their adoption. And so I wanted to touch on these because I think it's important to understand where the industry is and why, cloud native apps are in such demand, why they're being, sought after. And also, it's important as we go forward here to understand what that really means to you and what that by definition means, by those who created the cloud and what the goal is, right? So per the National Institute of Standards here, we'll see the definition of cloud computing has 5 main points. It's on-demand, self-serviced, deployment or procurement of computing services and computing resources and the related resources like storage, networking, etc., without the need to pick up a phone, call someone, or to put in a ticket request and wait for that to take place for you. So it is truly on demand. There's broad network access. By definition, it's connected to the internet, and it's easily accessible and readily accessible, and there's sufficient amount of bandwidth as well, theoretically limitless bandwidth for your workloads available to you. There's resource pooling. What does that mean? That means that we can basically take a bunch of servers, storage, etc., and we can define what we need, but what we are using is actually running on shared pooled equipment or pooled physical hardware. So our workloads might actually be running alongside and with other workloads that may or may not pose certain concerns. There are features in some of these public clouds, such as in Azure, Microsoft has something called enclaves, which literally to the CPU encrypt your workload and your compute of what you're processing through that physical hardware on that computer to be encrypted just for you and for your tenant, your account in the cloud. So they are not just virtually isolated, but there's some good solid security in place there taking place for resource pooling. Rapid elasticity is our 4th point, is the ability for a solution to scale on demand, theoretically to whatever demand your workload needs to bear. Examples are during National Super Bowl event, and you have your workload increases due to demands based on a commercial or an advertisement that your organization had, and you don't quite know just how much you need to anticipate in terms of workload. The request load that's going to come in. The cloud helps you with that because it makes it dynamic and it allows you to auto scale. Sure, you're going to get billed for that, but it's dynamic and it's not something that you need to prepare in advance for completely and say, you know what, I just don't know how much we're going to need in terms of resources and computing power. And then lastly, for cloud computing, measured services. So measured services are the ability to measure your consumption, like we just mentioned, of your compute, your storage, your bandwidth usage, down to fractions of a billable unit. So will basically be per second or per minute. Some resources are per hour. And then also on the bandwidth side, how much bandwidth are you using per kilobyte, et cetera. So this is the definition of cloud computing. With that, we have 2 types of movements or migration paths into the cloud from your on-premise workloads. And so these are actually comparisons taken from IBM, from their cloud learning section. And I just wanted to quote them here. So we have a lift and shift and we have a transformation. A lift and shift basically for all intents and purposes is taking your existing workload and literally just picking it up, moving it into a cloud environment and putting it down there and deploying it. No change to the architecture for the most part. It's a 1-for-1 on-premise to the cloud migration. So this would typically happen in the form of a migration to virtual machines. So either you have physical computers taking care of your workloads on premise or in a data center, or you will have virtual machines. You can migrate those to the cloud as is and run them inside of a virtual private cloud. Think of it as a virtual data center. So you're not changing your workload at all or how it's architected, you're just moving it. Transformation, on the other hand, is going to actually take your workloads and transform them into actually adopting and using the services that are available at these public cloud providers to actually add value to the workloads that you're trying to host to either internally to your organization or externally publicly facing to the internet. So that involves refactoring, that involves re-architecting, et cetera. And you basically have to take an investment there. It will be more costly upfront to invest into that transformation. But the reality of it is in the future, your pay-per-use ability to actually scale up and down as you need it is actually going to overall benefit you from a cost standpoint. So this is the difference between a lift and a shift versus a transformation. And to be honest, far too often, organizations will pick up their workloads, they'll move them to the cloud through a lift and shift and not take advantage of transformation. Either the intent was never there or the intent was deferred. We'll get to that some point. And so unfortunately, I've seen organizations too quickly just take a infrastructure as a service, it's known as IaaS approach, and just take workloads from on-premises, move them into the cloud without transforming them. And this basically becomes their impediment. They're really not adding value. They're actually running, a lot of times organizations will actually wonder, why is it so expensive for me to just move it versus just hosting it in the data center? And the reality of it is a lot of organizations will take a workload from a on-premises location, which currently has, say, 8 virtual processors assigned to it or 8 physical processors assigned to it. But that processor utilization is only at 5–10%. But they migrate them to the cloud, one for one, like for like, 8 virtual CPUs in the cloud from the 8 that they had on premises. And we end up with an inefficient workload, inefficient consumption of an inefficient consumption model of resources inside of the cloud for that workload. So now we're paying far more than we need to be. And the reality of it is it just wasn't scaled right. So what is cloud native? This talk is called Cloud Native Apps. And I just want to touch on what exactly is cloud native. Because if someone says, well, I moved my workload to the cloud. Okay, great, it's hosted there, but is it really a cloud native solution? Did you embrace the cloud and transform into the cloud? And so we'll go back to IBM for this. And this is basically where we can define what it is. It's not where the application resides, but how it's built and how it's deployed. It consists of discrete reusable components, right? They're known as microservices. And those microservices are building blocks packaged often into containers. It doesn't have to be packaged into containers, and I like to preface that. But often it can be packaged to containers. And that would be something that you've heard of is Docker containers. On the last talk, you heard about Docker containers, and we'll touch on that here as well through our demos. But just keep in mind that microservices are often packaged up in that way, and we'll discuss why in just a bit. But in addition to that, the actual components of your application can basically work together and are orchestrated together. They work independently of each other, so you can deploy each one independent of each other. And you can iterate over those individual microservices, deploying each one out separately without theoretically taking down your application. It just takes some planning and takes some design and architecture to do that. And so the last point that a cloud native app is the flexibility that this type of architecture, a microservices architecture, can add for you to basically add the agility and the ability to continuously improve. So with that, let's go ahead and take a look at some of what cloud native services look like on the two most popular clouds. And I know that there's probably questions here or someone wondering, why am I not comparing the Google Cloud platform? And the reality of it is that while it's catching up, it's simply nowhere near the market share that these two share. And I think it's fair to at least give these two leaders a comparison, as opposed to making this talk specific to any one cloud specifically. But to have the time to actually cover all three would just not be reasonable. Maybe next year. So in terms of what some of the cloud native services are, some of you may have heard the term serverless. And serverless, by definition, is the ability for me to deploy my application to a service that does not require for me to maintain a computer, a actual operating system with updates, with, you know, whether they're Windows or Linux system updates, and then updates to the respective applications, hosting application, you know, service. In the case of, like, say, the .NET, you know, application might be hosted inside of IIS, or it might be hosted inside of some other web server. I don't want to maintain those security updates. So serverless solutions are available and you know, for us to consume within the cloud. And so one of those is serverless functions. AWS Lambda, which was presented in the previous session, if you were able to attend, and we'll also have a short demo on that here on this session. And Azure Functions are two examples of serverless function offerings from both clouds. So you can deploy your code to either one. You don't have to worry about the server. You don't have to worry about the operating system. It's all hosted for you on the latest security updates. It can scale automatically up to, you know, your tolerable limit of cost, and, you know, you're billed on a consumption basis. And so that allows us to target either a API or a microservice type of architecture to one of these service offerings. And so we can wrap up the application and put it into one of these. And both of these services run .NET, they run Node.js and a couple other platforms, including PHP and so forth. Python can also run in these. And so these are some of the serverless function you know, options. Containers, you may have heard of. Containers allow us to wrap our functionality of our application inside of a typically Docker container, the most popular one being Docker. And we can containerize the app, basically set it in a sandbox, and then deploy that sandbox to an environment. And it's hosted for us by various services out there from the various cloud providers. So in the case of AWS, you can host this in ECS, which is Elastic Container Service. There's two ways to host ECS. One can be where you initiate the actual servers, which would be the virtual machines that these containers run on, or you can use something known as ECS Fargate, in which AWS and the management plane, the backplane, will basically take care of spawning the actual compute that your containers run on with, and they'll launch within, you know, compute that's running with the latest security updates, etc. So Fargate is a good example of a cloud native service. EKS, which is Kubernetes on AWS, Elastic Container Service, I put in here, even though you maintain your own virtual machines in that particular case, EKS takes and abstracts a lot of it for you so that you don't have to worry about the details, and you can easily keep them patched and updated, etc. But it does provide a lot more flexibility in terms of DevOps or CloudOps, concerns. And so on the Azure side, we've got container instances, which would be the equivalent of Fargate, really, on the Azure side, as well as AKS, which is their Kubernetes offering. And then for databases, we have some relational database offerings from both Amazon Aurora, which can run in MySQL or in Postgres compatibility mode. And we have Azure SQL database on Azure side, which is basically a Microsoft SQL Server engine running as a platform as a service offering for you to use. So those are your relational options. The two most common NoSQL or object-oriented database options are DynamoDB and Cosmos DB on those two respective providers. So storage, probably almost everyone that's attending here has probably heard of Amazon S3. If you haven't, it's a HTTP accessible file storage service offering, and the equivalent of that in Azure is blob storage. We'll also have the ability to use queues, where we can put messages in a queue for a microservices type architecture, and we have different offerings from both providers for those. Something similar to message queues are service buses. They're just a little bit more extensive, and we can do messaging between our microservices using these various offerings here from both providers. I'm going to skip over the native app platform for just a second and just talk about the other three. I probably should have reordered this slide. Web applications. So if you just want to host a web application or a simple API, you can do that very quickly inside of AWS using Elastic Beanstalk or something they have now known as Lightsail. And so that's a great way to get started if you're just getting your feet wet and you want to get into the cloud. The equivalent in Azure is the app service, where you can host web apps and so forth. You can also host containers inside of some of these offerings as well. So you can target your containers to these offerings as well. Just a little less heavy lifting to get set up. And that's why Amazon called it Lightsail. API platforms. So if you are exposing an API from your, from your application, API gateway and API management in Azure, respectively, these allow you to in a very configurable fashion, host multiple versions of your API, take care of scalability issues, take care of throttling issues, and even per user or per account throttling, so that you can bill your customers for consumption of your API, et cetera. These are really great offerings that allow you to, to front your API that's hosted in any number of other services where you're actually hosting your API. But this actually allows you to have like a proxy, like a front end, serving those up. And then from an AI ML standpoint, you have these various services here inside of AWS and Azure, SageMaker, recognition, which does video and image recognition services. We're going to have a demo on that next. And then machine learning and cognitive services as well. So those are the equivalent in Azure. All right. So with that, if we have any questions, I don't mind taking one really quickly right now before we start the demos.
No questions for now.
No questions yet. Okay. Don't be shy. Go ahead and anything that you want answer, I'd be happy to go ahead and do that. So, all right, so let's take a look at our first demo. So what we're going to do here is look at AWS serverless. So let's pull a couple things here. Let's pull up the AWS Management Console. And so here we're basically going to go ahead and take a look at Lambda, which is a serverless functions offering, which you may have been on Ramona's session in the last session. She did cover Lambda, and I was concerned we might collide there or we do share some overlap, but I'm glad that she really touched on different aspects of this. So what I'm going to do here is actually just say, you know what, let's take a look at a sample application that we can actually go ahead and deploy and see how relatively straightforward that is. So in the case of this particular demo, This is Visual Studio 2019. What I have here installed is the AWS toolkit for Visual Studio. It adds this AWS Explorer to it. It allows us to connect with credentials and pick a particular region inside of AWS where we'd like to target. And you can browse any kind of resources that you might have inside of AWS. Like, for example, I have this default VPC, which is called a virtual private cloud, and virtual public cloud as well, however you want to phrase it. Depends whether or not you're exposing it to the internet or if you're using it internally. And so this is just an example of integrating, communicating with AWS inside of Visual Studio. The nice thing about this is, in addition to this little explorer that pops up, we are able to also deploy our applications to AWS from within Visual Studio without having to worry about any of those additional details. So let's take a look really quickly at what this is. This is a .NET Core based project. And what I've done here is basically created a .NET Core web API. It has two controllers in it, a labels controller and a celebrities controller. And what this is going to do is basically have an API with two endpoints that's going to allow us to post images into those endpoints. And for the labels controller, we're going to actually take the image that's passed to us, and we're going to go ahead and actually push that up into the AWS recognition client through a detect labels request. And what it's going to do is it's going to give us back a response with a bunch of labels, and we're going to labels of the image. So whatever image we upload to it, it's going to analyze, and it's going to come up with a list of labels. And for each label, it's going to come up with basically a rating, a confidence score, which is a value of 0 to 100% of what confidence that machine learning model has on that particular label of what it found inside of the image. And so we're going to loop through those labels. We'll output some of those values to the console, and we'll also add them to the response of labels that we're going to send back to the client. So I didn't create a user interface for this, but what I did do is I basically went ahead and used Postman. And if you've created any APIs before, you'd probably have used Postman before. And Postman allows us to go ahead and look at calling an API. We'll pass in a value and basically be able to get a response back. So what we'll do here is we have basically a body of our request. And what I'll do first is I'll go ahead and actually start this particular piece of code. Now, what's cool is we're going to go ahead and host this locally inside of IIS Express from Visual Studio. And we just have a simple message that says that it's running on AWS Lambda. Now, obviously, it's not yet. We haven't deployed it yet. But when we do, we're going to be able to access it and basically make calls to it. But let's go ahead and actually make calls to it here locally. So we'll go ahead and we'll select a file. We have this cityscape of New York City, and I'm going to go ahead and actually upload this to the code here locally. And it's going to go ahead and actually make a call to the AWS recognition service, and we're going to get back a list of the actual labels that it feels are for that image and the confidence score for each one of those labels. And you can see that the confidence score sinks down further. Now, we capped this with a confidence score of 75 or higher. So this list could be far longer if we didn't limit that restriction. Let's go ahead and pick that other image where we have basically a group of 4 celebrities here. And we'll go ahead and send this image in and see what we get. And we've got a face, a person, there's a tie in, definitely a tie in the photo, some accessories, a suit, etc. So you get the idea. That's basically what this particular label service is doing, this label API that we're exposing, making use of the AWS recognition client. And similarly, the celebrities controller here We're also doing a 75% minimum confidence score. And what we're going to do is we're basically going to go ahead and actually recognize celebrities. So similar code, similar approach. And what we're going to do is we're going to loop through the identified celebrity faces in a photo, and it's going to give us some additional metadata and details. So let's take a look and see what that actually looks like. So let's go ahead and send this request in. So we've got the celebrities image, and we have the celebrities endpoint from our API, and it found these 4 celebrities with some very high confidence that these are the celebrities that were part of that image. Now, what's interesting is I've limited what we're outputting to our API here, but what we get back from the recognition client is actually more extensive. And we can actually take a look at the output from that recognition client here. So this is a list of all of the celebrities that it actually identified and the additional details that come out from there. That's not all actually that it actually includes. So let's just for giggles here really quick, we'll go ahead and we'll actually output this entire celebrity faces result that we get. So it's not just going to be our limited list of attributes. Let's go ahead and do this, and you'll see just how much data is actually coming back in that short period of time from AWS Amazon recognition. So let's relaunch this here locally, and let's go ahead and recall this API endpoint. All right. Let's take a look at this. So let's go ahead and actually copy all of what we have in here and stick this inside of Notepad++. We'll format it for JSON. And you can see here that we've got a lot more information. So we've got a face. It tells us where on a percentage basis inside that image did it find that face, the box, if you will, the bounding box, the confidence that we already saw. And look at all these emotions that it found, that the person was happy, they were somewhat surprised, but predominantly they're just happy. So that's a great thing. And landmarks, it tells us where the nose is, where the eye, the left eye, the every aspect of the face is, and some quality on the actual image. And you can see the primary emotion that's there. And we have an ID for that celebrity, and we have some URLs for that celebrity. So we can go to those URLs and pull up information on their profile, right? So you can see this is basically the output for all of those. So I'm sharing this with you just to give you an idea of what's possible there. And really this was done with some minimal code. A lot of this code here is just, you know, for my own purposes, you know, as a developer, just as part of the demo to make it a little bit more verbose for your benefit. But realistically, that code is really just this call. And that call right there gave us all of that information for that image, right? For that, for that image of those celebrities. So now we ran this locally, but what if we want to run this up inside of the cloud? Right? So how do we get there? So this is a cloud native capable solution. It's a lightweight API that could run as a microservice, and it's hosted in .NET Core. So it could target a Linux host. It could target a container. It could target Windows. It's very flexible. And so one thing that we can do is we can host this inside of AWS Lambda, which is serverless functions. It can host native .NET Core code. So let's go ahead and deploy this. Now I've set up the profile with my authentication already, but after you do that, it's really this simple. We're just going to publish it to AWS Lambda. And when we get here, we're basically asked to pick a stack name and a bucket name, and it just remembered what I had picked last time. I'm going to go ahead and actually name these. So what are these? So CloudFormation, when you go to deploy something in the cloud, you can deploy it manually through a portal, right? Through the AWS portal and work your way through this way by creating a function, or you can go ahead and deploy it through PowerShell scripts or through AWS CLI scripts, command line interface scripts. Ultimately, what's really happening though, in most of these cases is behind the scenes, you have an orchestration platform that's actually deploying these things, these resources for you, like the Azure functions or the Lambda functions are being deployed for you. And in Azure, it's known as the Azure Resource Manager, ARM. And in AWS, it's known as CloudFormation. So CloudFormation is a way for us to deploy these resources. And let's go ahead and actually start that. So every CloudFormation deployment needs a name of something known as a stack. It's a stack of resources that we're deploying. So I'm going to give it a name, and you'll notice it's asking me for an S3 bucket, and you might wonder why that is. It's because CloudFormation takes a template that gets placed into an S3 bucket, and it pulls it from that S3 bucket to then go and deploy it for you. So that's why we need an actual S3 bucket. So we'll start this process up. And as this gets going, it's basically going ahead and determining what it needs to do. It's going to rebuild our project. It's then going to zip it all up, and then it's going to upload to S3 both our code and the CloudFormation template. So now here we'll see that this is actually an integration to CloudFormation, and it's showing us the stack that it's creating right now. Let's go to the actual AWS console and go to CloudFormation here, and we'll actually see the same stack being created. So here's our Programmers Week 2021 stack that we are pushing up from Visual Studio, and the creation is currently in progress. So this won't take too long. If we drill into it, we'll actually see, we can go to the details of the resources here to see what resources are actually in deployment, which ones have completed. And you'll see that really where we're at right now is just the deployment of some of these specific permissions resources that are currently being applied. We've already deployed the function. We've deployed the API gateway. By the way, we're deploying an API gateway in front of that function to host it to the outside world. And all of what we're telling it to do, by the way, is happening here through this serverless template. Ramona went through a CloudFormation template in the previous session in one of her demos. And so that's what this is. This is a CloudFormation template using a AWS serverless API, let's call it macro or shortcut inside of CloudFormation. And we're deploying a .NET Core 3.1 runtime here to Lambda. And in addition to that, we have a API gateway in front of it. So that's part of it here. And you'll see that we're going to have an API URL come out as a result. So let's go back and take a look at this. You'll see that our creation is complete here on our screen. And if we come up here, we'll actually see that our stack has completed. So we're completed here. And now what we can do is we'll go to the actual Lambda function here and take a look at it, right? So we've got the function deployed. This is the actual Lambda function, and it's fronted by the API gateway. So if we go into the API gateway here, we can look at the actual API gateway itself. And this is the configuration that it's set up for us. I won't go into these particular details. Let me come back over here. And let's just go ahead and grab the actual URL. I want to use the one without the proxy. This is a AWS specific endpoint that I don't want to detail too much right now. We're just going to copy this link address here. And what we're going to do is we're just going to basically take our celebrity image here, celebrity endpoint, and we'll basically duplicate this tab, and we will change the URL that we're actually accessing here. Actually, this is just a name here. So we'll just call this Lambda. And the actual URL here will change. All right, so here's our endpoint for Lambda where we're hosting this that we just deployed. and we're going to go ahead and make this call. Now, I have no authorization or authentication requirements going on here. It's publicly accessible, and so no concerns there. And you'll see that we got the result back. You remember that we changed the code, and the result that we were getting back was very verbose. Well, I never changed it back, so when we deployed it, we had this whole verbose response coming through. And so here you can see our response coming back, and this here being hosted inside of Lambda on AWS. So pretty straightforward from a deployment standpoint, resource consumption standpoint. There really isn't much complexity to this particular solution. We don't have our metric data here yet. That will fill in here over the next 5 minutes. It's always a little bit behind, but basically, we have, let's see if I can actually drill in here. Maybe the details here will actually be available to us a little bit sooner than that primary dashboard. And we'll see the invocations here that are coming through. Nope, not yet. So again, like I said, it's a minute or two delayed. We'll go ahead and leave this on the table and move forward, okay? So that's using Lambda to host something inside of AWS in a very cloud native approach. So we'll go ahead and close this particular demo out. We don't need Postman anymore as well. And so next demo is basically going to be for containers. So you've possibly heard about containers, talked about it earlier, taking an application and actually wrapping it up inside of a Docker container and then hosting that inside of the cloud, right? So let's take a look at this. This is a Node.js application. And what we have is we have a single route, single page, if you will, with a single view here. It's an MVC type of model. This is Node with the Express framework doing the scaffolding for us here. So our primary page here, if we just take a look at it, we've got, we have a title, we have a form, we're going to be asking for a city and an input field, and we're going to have a submit button. And then we're going to have two conditions on the results. Either the city was not found or we have results for that particular city. And what we're going to be doing with this demo is we're going to actually call the Open Weather organization's open source API. And we're going to get the current weather at any city that we want across the world, across the globe. And we're going to output this metadata that we get back here to the page, right? So all this various stuff, including the wind speed and gusts and temperatures and such. So let's take a look really quickly at how we're going to be doing that. So we have an app API ID for the API. I encourage you to get your own API ID, app ID. This is going to actually be just temporary for this presentation, and it will not be working after I'm done with my demo. But what we're basically doing here is we have two calls. If someone gets the page, we're going to render the view. If someone posts back the form to this page, we're actually going to go ahead and call the API at openweathermap.org, pass in this path here. We're going to pass the city in, as well as the app ID, app API ID. And we're going to replace that token there, the city token, with the actual city name that we pass in from the form. And then we're going to basically load up, once we receive all that data, the JSON data, we're going to go ahead and send it back to the client through the weather data object. So that will be accessible to us there. So we can go ahead and actually run this through npm run start. This will go ahead and host Node for us. And what we'll do is we'll actually go ahead and open up a browser locally on port 3000, which is where it's currently hosted. That's what I have it configured for. And you'll see that we can type in any one of these city names. So we'll go ahead and type in New York. And here are our results. So we're running locally, but we're going to package this up and we're going to go ahead and actually send this up elsewhere. So my family actually is Lithuanian in heritage, so we could look up something in Vilnius. It's nice and cool there right now in the late evening, and so you get the idea here. right? And so this is what we're going to containerize. So let's go ahead and actually do that at this point. Inside of Visual Studio Code, what we're going to do, let me come here to Docker, and you'll see that we don't have any containers running locally. I have a container demo, and so I'm actually going to go ahead and let me actually remove all of these images from here. So we're going to start with a clean slate. I'm going to, by the way, here's that JSON response that we got from the weather API with all the raw data. So I'm going to terminate our local instance here of the Node web server, and we're going to go ahead and actually hit Control-Shift-P inside of Visual Studio Code, and we're going to build a Docker image based on the Docker file that we have here in our project, which tells us what it needs to launch and what port to expose it on, and so forth. So this basically just has the simple configuration information that's necessary to get this particular node project working. And so we're basically done. We've created a Docker container image called container demo locally, and we'll now see that here locally on our Docker. We could run this locally and test it out, but what we're going to do is we're going to save some time here real quick. In the interest of time, we're going to go ahead and push this up into Azure. So let's take a look and see how we might do that. You could go through the Azure portal here, and we could actually go ahead and actually set up a container registry, and then set up a container instance that pulls from the container registry our Docker image. Or we can just go ahead and do that in a scripted fashion. So that's what we're going to do here. We have a couple of Azure ARM templates. So Azure Resource Manager templates, like the CloudFormation aspect in AWS, that are going to deploy a container registry and then an actual container instance group for us that points to the registry. And we're going to do that through this PowerShell script. So you can come in here and feel free to change. I'm going to have a link at the end of this presentation to the GitHub project site. You can go ahead and actually download all of this code that we've been looking at. You're going to want to change the registry name that is globally unique across the entire Azure landscape. And so you're going to want to pick something unique to you. Otherwise, you would be good to move forward with deploying this. So what it's going to do is it's going to connect to Azure if we don't already have credentials there and prompt me to log in. I believe I'm already logged in. It's going to create a resource group. It's basically a list of resources. It's then going to create the actual container registry and deploy that. And then we're going to connect to that registry here. And once we've connected and we've established a connection, we're just looping through here to make sure we get it once it deploys and we're good to go. We're going to go ahead and apply what's known as a Docker image tag. So we're going to tag our container demo here with a reference to the Azure Container Registry so that we can then push that container up to that registry. All right. And once we've got that in place, we're going to go ahead and actually get the registry credentials pulled back down so that we can then create what's known as an Azure Container Instance. And so let's go ahead and actually run this really quickly here. So we're going to go ahead and actually deploy this particular project really quickly. Let me maximize the screen and we can take a look. So it created the resource group. It now created the registry. It's connecting to the registry. It's applying the registry tag. And now we're pushing that Docker container. And here you can see what's happening here. It's starting to push the different layers of the container. And I won't go into the details right now in the interest of time of what a layer is, but we can see here that we now have a resource group called Programmers Week 2021 demos. So far, there are no resources in this group because they are in the process of being deployed. But what we can do is we can look at the deployments over here and see what deployments are currently in effect in this resource group. We have the container registry deployment that succeeded. And let me come back here. As we're pushing this particular image, we don't have the container instance deployed yet, but we will here momentarily. And unfortunately, this is taking a little bit longer than I was hoping, but it should speed up here. I'll take any questions now because this could take another minute or two in the interest of time.
We don't have any for now.
Okay. Is anyone here?
Someone said thanks, so yes, but no questions.
I know. I'm just kidding. All right. So this is pushing up the largest layer of the container, which is predominantly the majority of the code and everything in the libraries that need to go up there. So it's pushing that up. As soon as this is done, it's going to start deploying the container instance to use this particular Docker container image. So here we are, we're creating the Azure Container Instance group. If I come back here to a list of deployments in the resource group, we are deploying the container instance, and this will be done momentarily. And once it is, we can drill into that. Actually, let's go ahead and go into this, and you'll see that as soon as it's done, it's going to give us a link directly to that resource, to that container instance. And from there, we're going to be able to actually access our container. So this should be any second now. There we go. So we're going to go to the resource. This is our container demo. We have an IP address for this. We have a fully qualified domain host name, which I'm going to copy to the clipboard so we can easily access this. And let's just take a look at the containers here really quickly. And you'll see that it pulled the container image that we uploaded, and then it started the actual container instance. And so here's our container demo with the container instance. Let's go ahead and actually access this particular instance that we deployed. And here's our container demo. So here we go. We've got our results here. And there it is, the temperature in Argentina. Sorry, it's in Fahrenheit, it's not in Celsius, forgive me. But here's our actual container running in Azure Container Instances, dynamically scalable, potentially limitless, and no server hosting it, no server for me to maintain, etc. So that's the beauty of the cloud here. So again, any questions, please go ahead and speak up now. I'm going to go ahead and put up the last slide here, which you may want to take a screenshot of, picture of. This is the actual URL for the GitHub site with all of the code for the demos that you just saw today. And thanks everyone for coming. Any questions?
Thank you, Darius. No, but we had really good reactions, a lot of thumbs up coming up. And
awesome.
Anthony says that he was just trying to keep up and write notes. That's why he was not asking questions.
And we're going to have these sessions accessible in the future to the public, recorded or not?
Yes, we will. We will upload them
awesome.
to YouTube and the Programmers Week website.
Awesome. Sounds great. Well, I hope everyone enjoyed it. Thank you so much for coming, and I hope you enjoy the rest of Programmers Week.